Lesson 3. Statics, Pressure, and Energy. Our final lesson covers statics, pressure, and energy. We start with Hooke's law, which states that within the elastic limit, the extension of a spring is directly proportional to the applied stretching force. When forces act at a distance from a pivot, the moment of the force is calculated by multiplying the force by the perpendicular distance from the pivot. For an object like a uniform meter rule to balance an equilibrium, the total clockwise moments must equal the total anticlockwise moments about the pivot. Moving on to pressure, it is defined as force divided by the area of contact. In a simple hydraulic jack, pressure applied to a small piston is transmitted equally. This means applying a small force over a small area can produce a much larger output force on a larger piston, assuming no friction losses. Finally, let us look at work and energy. Work is done when a force moves an object, calculated simply as force multiplied by displacement in the direction of the force. Energy takes different forms. For instance, the kinetic energy of a moving object is 1/2 its mass times its velocity squared. Because the speed is squared, doubling an object's speed gives 4 times the kinetic energy. Power is the rate of doing work or transferring energy, meaning 1 watt equals 1 joule transferred every second.